Hello, welcome back. So today I'm going to do a tutorial on the p5.js JavaScript library. So what it is, basically it allows you to draw shapes and everything like graphics with like JavaScript. It's basically a library for like doing stuff with a canvas, and it's pretty cool. And what we're going to do is to make a physics simulation with p5.js. Okay, so the thing that we're going to make is this. So basically, as you can see, this is a physics simulation of circles, and they're all bouncing around like randomly. And so we're going to take a look at how to use the library, how to make the physics work, like how exactly I calculated all of this, and also a few tricks to make it run more smoothly. So the first thing is to go to this website called p5.js.org. So what you can see is that it's just a website, and here is the start creating with p5 editor. And now if you just go here, it automatically takes you here, and you can just edit code like this. So if you do that loading, it gives you a square. So this I recommend you can log in so you won't lose your work when you reload. So this is basically the editor, and you can just use this to edit. Or what you can do is you can see there's a sketch files, you can just download them. Okay, so where you see here, if you run this, and then you can also do auto refresh. So you have a setup function and a draw function, and the draw function is called every frame, so that's 60 times per second, and the setup function is called every time you run this. You can see that create canvas makes a canvas 400 by 400. So let's just for example change this to 600 by 600, and you can see that it automatically updates, and now you have a bigger canvas. And the background color is pretty simple. It just draws the background. The color, this is a grayscale. So for example, you can do 255 is the biggest, and that's pure white. If you do 3 values, it will give you RGB, but 1 value you can just use for how bright it is. Yeah, so like for example, what you can do is there's an ellipse function, and with the ellipse function you can do this. So like 20, 20, I don't know, 50, 50. Okay, so this doesn't illustrate it too well because some of the values are the same, but basically the first value is the x direction. So if you do 50 or 100 here, and then like 60 here, 70, and you can see that 100 is 100 from here, and 70 is 70 down. The coordinate plane for canvases is that the top left coordinate is the 0, 0. Here is 600, here is 600, 0, and this is 600, 600. I don't know why it goes from the top to bottom, but I guess it makes sense for stuff like this. But so yeah, basically you have ellipses, and what you can do, let's say you declare a variable here, let x position equals 20, and now it does that. And you can't see that it's moving because the position is staying the same every time, but it's actually drawing it repeatedly many times. So let's just change the x actually that's the y. Let's just change the x to the x position. Yep, so now that's 20. And now if you of course if you plus 25, it just goes to 25. What we can do, for example, is if you, for every loop, x position plus plus. So in JavaScript, plus plus means add 1. And you can see from here that this ball is now moving. So that's basically the basics of p5.js. What else you can do is do a lot of different stuff. So for example, instead of plus something, you multiply it by 2 each time. And what this will do is, you can see it accelerates off into the distance. Okay, so now you can do other stuff. For example, there's stroke weight. If you do that, now the stroke weight now 20. So that's basically how you can do modify stuff. There's a great documentation where you can go to p5.js.org. Yeah, so you can do stuff. But physics simulation, we don't actually need to do ellipse. We can actually just do a point with x position and y position. But we don't have that variable yet, so let's just keep it as 50 something. If we do that, it is working. If we zoom in, you can see a very tiny dot. So yeah, we have to change the stroke weight. Let's change that to 25 for now. And let's just do something pretty simple. Let's actually also give it a y position of 25. And now if you want to do a lot of physics stuff, you can velocity and acceleration. Let's just duplicate that a bunch of times. Yeah, you can declare it. So let's say x velocity and then y velocity and then acceleration, just like that. Or we can do it start off the velocity as 0 for both of them. And the acceleration I will be 0, and y acceleration will be 0.1 for gravity. Position, now you know what we can do is x position plus equals x velocity, because like in physics the velocity is basically how much the position moves in a certain amount of time. So what we can do is that, and then now if you just select the line, we just duplicate it. Y position equals y velocity. Now you can see that it's still not moving because the velocity is 0. If we change the velocity to 1, it will move with like 1, and then if you change it to 2, it will move like this. Great. Y velocity, now you do x velocity, and the x velocity is offset by acceleration, so x velocity is plus equals acceleration, and y velocity also plus equals y acceleration. Now what you can do is you can see that it's falling downwards because the velocity is changed by the acceleration, and then the acceleration is like. Now you can see that it's pretty bad, but you can simulate something that falls. This, for example, if you change the x velocity to, it kind of looks like a parabola. That's basically what you can do with it. By the way, if you remove the background, what happens is it paints a line like this, because the background actually basically doesn't erase what's behind it. The background basically just paints it over something, so you don't see the stuff previously. But so yeah, if you call this loop, it just does that. Let's say we wanted to bounce off the floor somehow. If you think about the physics, what you can do is you have to see how do you see it bounces off the floor. You can see it the position if it's touching the floor. So let's look at the y position. So we can write if statement y position greater than 600, greater than or equal to is probably better, but greater than 600. And what happens if an object hits the ground? What do you think happens? It's not the position that's negative, because so it will just suddenly jump to somewhere else. It will be the velocity that's flipped around. So what we can do is basically by velocity, and then multiply that by -1. Yep, if you can look at this, it will work. So what it's doing is that if you hit the bottom of here, reverses the velocity and moves it back somewhere else. Now we can do this thing to the exact same way with the other walls. So for example, if the x position is greater than 600, we do the x velocity. And also we can do, because there's two walls, so if x position is greater than 600 or if it's less than or equal to 0, what you can see is that we made a really simple physics simulation that it bounces around. Alright, that's it for video 1, and I know that everyone says this, but subscribe and like the video if you liked it, because that's apparently the default thing that you're supposed to say on YouTube, so bye.